Welcome. I am not here, as you notice. Thank you for scanning the QR code. Open up your composition notebook. Today we are working on pages 118, 119. Today's date is the 11-28, and we are going to be learning order of operation for the next 3 days. You've learned order of operations since elementary school, so this is just a little more strenuous in the mind. So let's look at our number routine. 2 cubed times a squared equals to 72. Can you find this value of a so it will equal 72? Remember to write this on page 118 of your notebook. So if you want to pause it at this time and have time to do it, please do so. Welcome back. There's several ways you can answer this. One way you could do it is the following. What is 2 cubed equal to? 2, the factor is 2. It repeats 3 times. 2 times 2 times 2. A squared, that's A times A equals 72. What is 2 times 2 times 2? That's 8. 8 times what is 72? I believe it's 9. And what are the two factors of 9? 3 times 3 is 9. So A equals 3. Another way you could have done it is you have found the factors of 72, the prime factors. So what makes 72? 8 times 9. What are the factors of 8? 4 times 2. What are the factors of 9? 3 times 3. Can you break down 4 into prime factors? Yes, 2 times 2. Can we break down a 2 into two other different factors? No. Circle, prime, 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 prime. I see 2 repeats 3 times 3 repeats twice. Hey, that looks like what we saw on our first page. A equals 3. So let's check our homework from the previous night. If I was here, this would have been a grade, just let you know that. So take out your homework. It was the worksheet that you got from yesterday. It is going to be taped onto page 116. So we see number 1 is 47. Number 2 is, so 1 is prime, 2 is prime, 3 is composite, 4 is prime, 5 is neither because it only has one factor, and 6 is composite. Pause it if you need to. Number 7, what are the prime factors? 2 times 3 times 11 makes 66. And here's the reason why. For 120, it's 2 cubed times 3 times 5. Some of you may have written it as 2 times 2 times 2 times 3 times 5, but we prefer to write it using exponents. Number 13, how do you break down 300? 3 times 100, or 3 times 5 times 2 times 5 times 2, or 2 squared times 3 times 5 squared. Number 14, how do you break down 1,265? Divide by 5. 5 times 11 times 23. And number 25, if to find the area of this rectangle, you multiply the length and the width. 200 times 90 is 18,000. And what are the factors of 18,000? 18 times 1,000. 9 is 9 times 2. 18 is 9 times 2. 9 is 3 times 3. Which factor repeats twice? 3 repeats twice. And that is our homework. So please now tape your homework onto page 116. Welcome back. Tonight there is no homework. It's no family night. All right, so you have this on your notes. This is the 5th grade STAR question. I don't know if you remember this. This is question number 12 on last year's STAR. What can you find the value of the expression shown? This is an order of operation. You have learned how to use learn order operation. The only difference between junior high, 6th grade, and 5th grade is our order operation has exponents and negative numbers. In 5th grade, it's without the exponent and it's just positive numbers. So I'm going to give you time to solve this on your notes. So when you're ready, please come back to this video. Welcome back. So which one did you find as the answer? 8.4, 15.6, 12, or 19.2? Well, let's see this. First of all, it's 4 groups of 4.5 minus 2 groups of 1.2. So we need to do inside the grouping symbol. So let's look inside this grouping symbol. What is 2 groups of 1.2? That'll be 2.4. So So 4 groups of 4.5 minus 2.4. So, and what is 4 and 5/10 minus 2 and 4/10? It is 3 and 1/10. Stop. 4 minus 2 is 2.1. So 4 groups of 2 and 1/10. What is 4 groups of 2 and 1/10? 2 and 1. 4 groups of it is 8.4. It is letter F. Letter F. So so today we're going to be learning, sorry about that. I don't know why there's an announcement. So again, it's 4 groups, so F. So that's what you got. So today we're going to be learning order operation. Where do I start? A numerical expression is a combination of numbers and operations. So an expression is, if you notice, do you see any equal sign anywhere? No, it's just a combination of numbers and operation. So there are blank numbers in this expression. How many numbers do you count? 3. So fill this in your notes. So if you think you could fill in these in on your notes without me try to, you may pause at this time and then come back. So these numbers are 3, 4, and 2. There are how many operations in this expression? 2 operations. These operations are addition and multiplication. So you evaluate an expression by finding its value. That means, in other words, you're just going to work out the problem, like work it out, like going to the gym or something. Jack and Jill were asked to evaluate or work the problem out of 3 plus 4 times 2, and they both got different answers. So you are going to determine who is right. Is Jack right or Jill? Jack and Jill. Who is right and how do you know? So write this in your notes. Well, welcome back. To make sure everyone gets the same results, mathematicians have agreed on a set of rules called the order of operation. So last year, you learned something called PEMDAS. We do not use PEMDAS at all. It's like, please excuse my dear answer. That's so elementary school. That's a trick. The only thing that I would like to talk about PEMDAS is when you do PEMDAS, that's parentheses, then exponents, then multiplication, division, and adding, subtracting. The last step in PEMDAS or order operation is addition and subtraction. That's very important for us, the way we do order operation at our school. What you are going to do is you're going to circle or highlight any addition and subtraction operators that are not in any grouping symbols such as parentheses, bracket, and wherever these are. Then you solve for the term. So what we do in order operation, we break problems into terms and operators. You say, huh? Well, let's look at this one. For example, you are going to circle or highlight any addition or subtraction. So here's our numerical expression. Do you see any addition or subtraction? I see it right here. So you highlight this. So the terms, the first term is 3. The second term is 4 times 2. Notice how this operator separates 2 more expressions, 3 on the left side and 4 times 2 on the right side. Now you can solve it. So what is 3 on the left side? It's just 3. And on the right term, you see 4 times 2, which is 8. So 3 plus 8 is 11. That's why Jill is correct. She was able to separate this. So let me get my highlighter and show you this. So highlighter. So we separate it from 3. 4 times 2 is 8 on the right side. 3 plus 8 is 11. What Mr. Jack did is he combined these two and then multiplied by 2. That is not correct. Addition and subtraction is the last operation in order operation. That is why we are separating it, the terms, and then we add it at the end. Let's look at another example. And then we'll do some 45 divided by 3 minus 7 minus 3 squared minus 1. So do we see any operators here of addition, subtraction? I see it here and here, so I highlighted it. Do you see the terms? The first term I see is 75 divided by 3. The middle term is 7 minus 3 squared. And the last term is just 1. So let's solve the first term. How would you solve 75 divided by 3? It's 25. How would you solve the middle term? 7 minus 3 is 4. And what is 4 squared? 4 times 4 is 16. And the last term is just 1. So 25 minus 16 is 9, minus 1 is 8. We do not do all like the PEMDAS actually, like look for the parentheses and look for the exponent, look for the, that is way too much thinking for us. What we do is we solve it just like in algebra, separating terms and operators. So we are now going to practice some on your own. As you can tell, there are 8 questions here. If you would like to, let's do number one with me, and then you pause it and then come back and see how you did. I'm okay with that, whatever you want to do. So number one, so again, my highlighter. You do need a highlighter for today's activity. So if you don't have one, go look in the bucket. In the middle of the bucket, there are highlighters. All right, so number one, do you see any operators here? Any addition, subtraction? I see it right here and here. So what is the first term? The first term is just 25. So we write 25. The middle term is 14. And the last term is 3. So 25 minus 14 is 11. Plus the 3 makes 14 is the answer. Wait, 25 minus 14 is, yeah, plus 3 is 14. Number two. So number two, let me get my trusty highlighter. I highlight any addition, subtraction operators. So do you see how this operator has broken it into 2 different terms? What do you see in the first term? I see a 42. What do you see on the right term? 6 divided by 2. And what is 6 divided by 2? 3. 42 plus 3 is 45. I hope you find this way of solving order operation easier instead of using all the mnemonic trick of please excuse my dear Aunt Sally of PEMDAS. Leave Aunt Sally alone. She's tired. Number 3. Do you see, again, you should have paused and worked on this and then come back and do this. You should not be sitting here watching me do the work. This is just to check your work. So here are the operators. So can we solve the left term? In the left term, I see 39 times the group of 15 divided by 3, which is 5. And what is 39 times 5? That's 45, carry the 4. 15 plus 5 times 3 is 15 plus 4 is 195. In the right term, I see 16. What do they want you to do with the left term and the right term? Subtract the 2 numbers. 195 minus 16, let's regroup, that's 9, 7, 179. Number 4, welcome back. Hopefully you haven't doing number 4. Let's highlight any operators. Highlighters right here. I see right here, but then you're gonna say, but what about this one? This is addition, subtraction. It needs to be outside grouping simple because you're breaking it into terms and operators. So on the left term, what do you see on the first term? I see 48 divided by 8, which is 6. What do you see on the right term? 5 groups of, what is 7 minus 2? 5. 5 groups of 5 is 25. What do they want you to do with the first term and the second term? Add them up, and you get 31. Number 5, get your highlighter. Highlight any operators. I see right here. So on the left term, what do you see? 7 squared. And how do you write that as repeated multiplication? If 7 is a factor, it repeats twice. 7 times 7 is 49. On the right term, I see 12. What do they want you to do with the left term and right term? Add it up. 49 plus 12 is 61. Number 6, highlight any operators. I see an operator right there, so I'm going to highlight this operator. So what do you see on the left term? On the left term, I see 34. What do you see on the right term? 8 squared divided by 4. Okay, how do you use exponent again? Oh, 8's a factor, it repeats twice. What is 8 times 8? 64. And what is 64 divided into 4 groups? 4 goes to 6 one time. 4 goes to 24 6 times. So it's 16. So the left term is equivalent to 34. The right term is equivalent to 16. And what do they want you to do with the left and right term? Subtract it. 34 minus 16, regroup. That would be 28. Yeah, 28 is the answer. Number 7 and number 8, get out your highlighter. So highlight any term. Oh, none here. And here, I see right here. Before you say, but what about here? Again, we're looking at outside of grouping symbols. So let's look at number 7. Number 7, there is nothing. So we just solve. So this is the whole term. So we just solve it as you see it. So 45 divided into 3 groups is 15 times, and what is 2 cubed? That's 2. The factor is 2, repeats 3 times. 2 times 2 is 4 times 2 is 8. And what's 15 times 8? 15 times 8 is, 8 times 1 is 8 plus 4 is 120. That's 120, by the way. And number 8, the left term is 4 groups of 5 squared minus 12, and the right term is 6. I'll solve the right term first. That's easy. The left term. What's 5 squared? That's 5 times 5, which is 25. So what's 4 groups of 25 minus 12? 25 minus 12 is 13. 4 groups of 13, that's 13, 13, 13, 13 is 52. 52 minus 6 is, regroup, 42 is the answer. So the last problem I want you to do is Peyton and Mackenzie, this is error analysis. We're asked to simplify the numerical expression below. Peyton and Mackenzie each simplified the expression but came up with different answers. Their work is shown below. Who is correct? Explain your reasoning. Well, Peyton says it's 23. Mackenzie says it's 35. You know, I don't trust anybody. Guys, you should only trust yourself. So I'm going to get my highlighter and highlight the operators right there. Don't highlight that one. That's an inside grouping symbol. So let me get a different pen color. The left term is 3. The right term, 4 groups of 5? 4 groups of 5 is 20. So what do they want you to do with the left term and right term? Combine them. Oh, Peyton is correct. 23 is the answer. Let's see why Mackenzie. Oh, she didn't highlight this. What she did is she combined the 3 and a 4 right away and times it by 5. No, girl. You have to separate the terms by highlighting the operator. So Peyton is correct. All right, well, thank you for watching this video. Hopefully you had a blast.